Hi guys, and welcome back to this interesting discussion of reduction formulae, trigonometry. Yes, we studied triangles, geometry, and of course we're introducing some funny stuff which are interesting and intriguing. So we have covered so far the 90 minus reduction, the 90 plus reduction, and the 180 plus reduction. And we know the 90 minus reduction will give us or will throw us somewhere in the first quadrant. We know the 90 plus reduction will throw us somewhere in the second quadrant, and the 180 plus reduction will throw us in the third quadrant. Okay, now we're going to do the 180 minus. Okay, and let us see where that throws us. Can you guess? Yeah, I'm sure you got that one right. It must leave us somewhere in the second quadrant. Now, our theta, as I said, for this exercise will be 36.62. So let us see what is 180 minus theta. So 180 minus 36.62 gives me what? 143.38. So I'm going to go ahead here and rotate this angle, okay, anti-clockwise. So I'm going to rotate about around the point. There's my figure. And what must I punch in? 180 minus theta is what, guys? 180 minus theta, we have established that it should give me rather 143.38 degrees. So I'm gonna go ahead then and rotate, and there is my rotation. Now I'm gonna measure this angle here and see if it is 36.2. Then we know the reduction, the thing went quite well. So let us see. It seems like we got this right. So yes, there's the angle, 36.2 so degrees. So that means we have done this uh, quite well. And I want us to notice, remember, in this case, our point of reference or our concern here is just the R, okay, is the hypotenuse in other words. So this means I've got to shift this a little bit. Look at my hypotenuse. Remember, hypotenuse at point D. So look at where it is. It is quite somewhere here. Okay, you see where it is there. So it is right on the point 180. Okay, so it should not actually be quite there. I think it should be, it should actually be where, yeah, to be quite accurate, should be where the C is. So the C as in the C prime, okay? In this case, we haven't actually done much reduction. So let us go ahead and reduce that. It should, so it throws us somewhere to 106.76. So I'm gonna go ahead and take this figure here and rotate it around the point. I am doing this, it might seem like it's tedious or so, but I'm doing this so that you can get the idea. There is something very nice that I want you guys to get out of this. So there I am, and I have my point D prime exactly where I want it. So what do we have here? Here is theta, okay? Here is theta, right? And here is 180. So if I say 180 and I subtract theta, I land then, okay? So what are my coordinates here? -4 and 3. And remember, this is x and that is y. Okay, that's one thing that I wanted us to establish. So we first went to 180 really minus theta, so it threw us off here, but we know actually what we want to literally rotate was the point D and not the point C, so we took this back, and That's exactly what has happened. The R is the important thing here, or is the main thing, if I may say. So we have that. Now let us go ahead and see what are the news. In the first quadrant, obviously we do all of this in relation to the first quadrant. In the first quadrant, we know this by now. This is 3, that is 4, that is 5. So sine theta is 3 over 5. Cos theta is 4 over 5. And tan theta is 3 over 4. You can go ahead and figure out the cosec, the sec, and the cotangent. I'm going to come straight here in the interest of time and go and figure what sine 180 minus theta is. Okay, so let's go. What is it? Maybe I should just write this down here. Okay, remember sine of 180 minus theta, okay, should be, we still go with y. What is r? 5. Oh, but wait a minute. This is just sine theta. Bravo. As I said, I will not do much explaining because I am under the impression that you've got the drill from the 2 previous videos. As we go for cos, cos should be x over r. But 4 over 5 is just what? Cos theta. So we've got minus, and you can guess, again, the reduction for tan 180 minus theta. It's going to be y over x, okay? So there we have minus tan theta. And bravo, guess what? We have made it, guys. We have made it. And that is the reduction for 180 minus theta. I hope you are having some fun here. You can see it's just a matter of rotating, of rotating the points. So what does this mean, guys? It means sine 36.62, okay, which is 0.596, okay? It means that it must give me the same value, okay? And please say that with me. Yes, it must give me the same value as sine 180 minus 36.62. Okay, so that's just about it. Instead of going the long way and saying sine 180 minus 36.62, why don't you just go straight and say sine 36.62? You see, that's the argument behind reduction formula. And as I said, let me repeat this, repetition is part of the process of learning. We are doing this so that we can be fast, we can be efficient when we simplify trigonometric expressions, of which some give you maybe a nightmare. We're gonna use reduction formulae, guys, a lot when we prove even some of the trig identities or when we simplify. While at that, may I mention, most of the questions for this section, okay, will be around routine knowledge, routine calculations. So that's most of the stuff that you guys will be faced with, that you guys will have to do. Right, in the next video, we close off the talk on reduction by discussing the 360 minus and the 360 plus reduction. So till then, I'll catch you guys later. Cheers.